So when we're talking about trig identities, we're going to have to talk about these basic trig identities that are on page 891 in your book. Alright, so you see the type of problem we're doing over here. We want to find the sine of theta if cosine of theta is equal to 1/3, and theta is in between 270 and 360 degrees. So we know it's in the fourth quadrant, right? So using this type of problem, I've showed you just drawing a right triangle in the fourth quadrant. I'll do it again just to kind of remind you, but I do want to look at these identities here. So you've seen this one, tangent of theta is equal to sine of theta over cosine of theta. Well, reciprocal cotangent is cosine over sine. You've seen these before, the reciprocal identities. Sine of theta and cosecant of theta are reciprocals of each other. So sine of theta is equal to 1 over cosecant, and cosecant of theta is equal to 1 over sine of theta. So you've seen all these. These are the new ones right here, these Pythagorean identities. These three right here are brand new to you. Okay? And another thing I wanted to show you, page 892, each of these trig functions is positive or negative in different quadrants. Now if you pull out your unit circle, as you recall, it gives you sine and cosine. Remember, sine is the second of the ordered pair, cosine is the first. So sine would be the y value, cosine would be the x value. So the y values are positive in the first and second quadrant, and they're negative in the third and fourth. And the cosine, the x values, so the top half will be positive. So the right half, so in the first and the fourth, and then on the left half, in the second and the third, they're negative, for the x values. Okay, and then there's the rest of them here, just so when you're going through these problems, you know what you're looking for. Alright, so again, I've showed you before how to do these problems using just drawing a right triangle. So we know it's in the fourth quadrant. Alright, so I'm just going to draw the fourth quadrant. You recall cosine is adjacent over hypotenuse. So the hypotenuse, let's think about it as the radius. So remember, the radius was, think about the circle in the unit circle, right? So there's our radius. And then, as you recall, there's theta. We always refer back to the x-axis. So there's my x-axis. Alright, there's the x-axis. I'm referring back to the x-axis, so that's why I dropped the perpendicular. And then, since this is theta, here is adjacent. There's adjacent right there, which is 1. Well, there's 3. Well, we can find that missing leg using Pythagorean theorem. So leg squared plus leg squared is equal to the hypotenuse squared. So I have leg squared plus 1 squared is equal to 3 squared. Now I already know you know the math. So leg is equal to square root of 9 minus 1. So leg is equal to square root of 8. And if you recall, square root of 8 can be written as 4 times 2. So leg is equal to 2 times the square root of 2, because the square root of 4 is 2. Alright, so we have this leg, and it's negative because it's in the negative y value. So 2 times the square root of 2. Alright, so now they're asking for sine. Well, sine is sine of theta is opposite over hypotenuse. Okay, so sine of theta, opposite is negative 2 times the square root of 2. Hypotenuse is 3. So the sine of theta is negative 2 times the square root of 2 over 3. Alright, now I want to use these trig functions here. So what we need to do is we need to look to see, is there some relationship between sine and cosine? Do you see any sine and cosine relationship? So right here in the Pythagorean identities, cosine squared plus sine squared is equal to 1. Move that. Alright. So, we have, here's the second way of doing it, cosine squared of theta plus sine squared of theta is equal to 1. Since I'm solving for sine, I'm going to get rid of cosine. So sine squared of theta is equal to 1 minus cosine squared of theta. Alright, well, I don't know what sine is. That's what I'm solving for. 1 minus, well, they told me cosine was 1 over 3. So 1 over 3 squared. So sine squared is theta is equal to 1 minus 1 over 9. Sine squared theta is equal to 8 over 9. So 1 minus 1 over 9, 8 over 9. Now, take the square root of both sides. Taking the square root. So I have sine of theta is equal to plus and minus. Remember, two answers. Square root of 8, square root of 2 over 2. Well, square root of 9 is 3. And now, if we come down here and we look at this, in the fourth quadrant, sine is negative. Alright, so sine of theta is equal to negative 2 times the square root of 2 over 3. See, the answers are exactly the same. Exactly the same. So it doesn't matter which method you use. You notice we get the same exact answer. Alright. Let's look at another one. Let's look at another one here. If I ask you to find secant of theta if sine of theta is equal to negative 2 over 7, and this time theta is going to be greater than 180 degrees and less than 270 degrees. So 180, in between 180 and 270, here is the third quadrant. Alright, so we're in the third quadrant. In the past we've done where we looked at it as you know, I would have drawn the right triangle in the third quadrant, but I want to look at this thing. I'm looking for a relationship between secant and sine using these trig identities. So secant and sine. Well, if we look down, we see tangent squared of theta plus 1 is equal to secant squared of theta. Alright? Well, secant is right here is the inverse of cosine. So secant of theta is the inverse of cosine of theta. Well, what can we get here? So if we think about this, here's our right triangle again, and I keep going back to this. Right? Keep going back to this. Here's my right triangle. Sine, we said we were in the third quadrant, so we're down here. There's my radius. That's 7. Drop a perpendicular. We're always referring back to the x-axis. So now this is opposite over hypotenuse. So here's where that negative comes into play. How can I figure out this adjacent side? Well, use Pythagorean theorem again. Right, we'll spare all the math this time. So leg is equal to 49 minus 4. Just squared 7. I squared negative 2. Subtracted them. So leg is equal to square root of 45. And 45 can be written as 9 times 5. Square root of 9 is 3 times the square root of 5. So adjacent is a negative. Is negative 3 times the square root of 5, because we're in a negative x-axis. Alright, so cosine is adjacent. So I have secant of theta is equal to 1 over cosine is negative 3 times the square root of 5 over 7. Now if you think about this enough, we have 1 divided by a negative 3 times the square root of 5 over 7. Well, I cannot divide by a fraction, so I have secant of theta is equal to 1 times the reciprocal, negative 7 over 3 times the square root of 5. When we multiply that together, this out the way, when we multiply this together, we end up with negative 7 times the 3 divided by 3 times the square root of 5. Got to rationalize. So times the square root of 5 over the square root of 5. So secant of theta is equal to negative 7 times the square root of 5 over 3 times 5 is 15. Alright, so secant of theta. We did all that work to get secant of theta. Alright. Now, another way we could have thought about this, right? Another way we could have thought about this is tangent. Tangent squared plus 1 is equal to we could look at it and see tangent squared plus 1. Right? Tangent squared theta plus 1 is equal to secant squared of theta. This is a little after the fact, but I just want to show you how this works. So tangent, as you recall, is tangent is sine over cosine. So we already know sine of theta, cosine of theta, is just going to be negative 3 times the square root of 5 over 7. So I have negative 2 over 7 squared divided by that sign, cosine, is negative 3 times the square root of 5 over 7. That's also squared. Add 1 equal the secant squared theta. So up here I have 4 over 49 divided by, when you put all this in your calculator or doing some mental math, we do some mental math here. 3 squared is 9. 9 times 5 gives me 45 over 7 squared, 49 plus 1. And again, think about what happens when you divide by a fraction. Alright, so when you divide by a fraction, let me do some writing over here on the side. We have 4 over 49 times the reciprocal, so the 49s would cancel. So I have 4 over 45 plus 1 is equal to secant squared of theta. Now yes, I agree, this is all calculator work, but it's nice to know where that stuff comes from. So we have 49 over 45 is equal to secant squared theta, square root 7 over 9 times 5, if you agree. Right, that's plus and minus because there's two answers. And then secant, we talked about way up here. We're in the third quadrant. Way up here, secant in the third quadrant is negative. So I have negative 7 over 3 times the square root of 5 times square root of 5 over square root of 5. Negative 7 times the square root of 5 over 15 is equal to secant of theta. Alright, there's a lot of work here, but a lot of this is just simple algebra, manipulating expressions.